สวัสดีค่ะดิฉันทิติมาศรีอุทารวงศ์ขอต้อนรับทุกท่านเข้าสู่สัมมนาออนไลน์ในหัวข้อ How COVID has highlighted the need for functional packaging technology ร่วมจัดโดย Informa Market และบริษัท Mitsubishi Gas Chemical Singapore ในวันนี้นะคะเราจะได้รับฟังเทคโนโลยีใหม่ๆที่ใช้สำหรับบรรจุภัณฑ์ที่จะสามารถยืดอายุการใช้งานและมีความปลอดภัยสูงและในระหว่างสัมมนานะคะหากท่านมีคำถามใดสามารถพิมพ์คำถามในช่อง Q&A ด้านล่างได้เลยนะคะและเพื่อไม่เป็นการเสียเวลานะคะดิฉันขอกล่าวต้อนรับผู้ดำเนินรายการของสัมมนาในวันนี้ May I invite Mr. Albert Lim, Senior Manager of Mitsubishi Gas Chemical Singapore, moderator of this webinar to provide you with an overview of the session. Welcome, Mr. Albert Lim.
Sawadee krap. Thank you and welcome. Thank you to all the Thai participants as well as the international participants for joining our MGC ProPak webinar on functional packaging using MX Nylon. I would also like to thank Informa Markets as well as MGC Japan and our industry partners, Mobile Color, for supporting our event. COVID-19 has highlighted various issues. It has highlighted the importance of safety and security for both food and non-food products, as well as the ability to enable the availability of both food and non-food products over wider geographies. I believe functional plastics can help to achieve all these objectives, and MX Nylon is one of the products that are enabling functional plastics, functional packaging. So I also believe that MX Nylon and plastics in general, functional plastics, are able to also reduce greenhouse gases and is a solution to the world's various problems, and it is not a problem in itself. I will leave the time to Ryan to share with you the technical aspects of MX Nylon. And during the sharing session, please feel free to send your questions to the Q&A box. We will respond accordingly either in the box or during the Q&A session after the presentation. If we are unable to fully answer all the questions, we will be able to get back to you post-event. Please give us your attention. Thank you for joining us. Ryan, please go ahead.
Okay. Thank you, Kunan and Mr. Albert, for the introduction. Before I begin, I would like to give special thanks to Informa Markets for arranging this webinar. Today, we have Miyabe-san from Mitsubishi Gas Chemical Japan, and Mr. Albert Lim and myself are from Mitsubishi Gas Chemical Singapore. At the same time, we also have Mr. Per Larsen and Mr. Anders Oslon from Mobile Colors, who are the expert in dosing unit, who will be able to answer any questions relating to dosing units at a later time. So I would like to first introduce our company, Mitsubishi Gas Chemical. It's a Japanese company headquartered in Tokyo. We are a company that deals in chemicals, develop business for a wide range of products from basic to specialty chemicals and advanced material, where we have two business units, basic chemical business sector and specialty chemical business sector. From our company, we have products such as methanol, which is a feedstock for some chemicals, hydrogen peroxide for aseptic filling system for beverage industry, oxygen absorbers for preservation of food in the food industry. And the team who are present today with us comes from the MX Nylon team, which is used in the packaging industry for barrier in improving shelf life of the products. So in this COVID-19 pandemic, we have all seen disruption in supply chain globally, closure of food establishments and empty shelves in convenience shops as a result of food hoarding, including paper product hoarding. This has actually caused greater stress on the supply chain for food product. As a result, the requirements for longer shelf life has been greatly magnified. Food packaging has also become a solution for fail-safe, where consumers are faced with the worry of contamination from COVID-19 viruses. Furthermore, with the increase of people working from home, the sales of ready-to-cook and ready-to-eat food has gone up significantly. So what are the challenges that COVID-19 has bring about? So as previously mentioned, supply chain disruption has led to countries who have actually started to be more concerned about food security and availability and food product shelf life, to increase the shelf life of the different food for the people. So if the worries for the impact of environment from food wastages and to reduce the total food cost. Second, ensuring food safety, thereby enabling food processing to extend the shelf life as well, and reducing in-food additive by consumers' requirement. So thereby enabling higher value food. So in this current market, most consumer believes that plastic is one of the greatest cause or the biggest problem for greenhouse gas emission and carbon footprint. Shall we now take a closer look at this emission value taken from a scientific online publication that focus on large global problem called Our World in Data. This report is actually funded by Oxford University and Melinda and Bill Gates Foundation. So over here in this report, you can see that the different product or the different activities is actually color coded into the different colors, and packaging, which is highlighted in gray. If you were to, so if the packaging which is highlighted in gray, if you compare to the various types of product that is manufactured, it is actually a very small in comparison, and the emission is very low as compared to land use changes or farms, or even the processing. For example, beef, lamb, prawns, fish, egg, rice. So all these gray areas are actually much smaller as compared to all the farming activities. Of course, under the packaging, we have other materials such as glass and aluminium, which has different carbon footprint. But all these packaging materials act as a solution to increase shelf life, values, and also the safety of food product. So packaging is not a solution. Packaging is a solution and not a problem, because packaging increases the shelf life of food product, therefore increasing the value of the food, and in this COVID-19 allows and improve the safety of food. So thereby making the production of food by reducing the carbon footprint of food losses, making it more environmentally friendly. So what is MX Nylon? MX Nylon is a polyamide nylon that is made by Mitsubishi Gas Chemical. It's an innovative barrier packaging material that provides excellent gas barrier properties and has a wide processing range, which is compatible with other resins. So traditionally, most people believe that moisture is the biggest cause for shelf life. However, therefore, PE and PP were developed, and these two resins have very good moisture barrier. However, people started to notice that oxygen is also causing a problem in shelf life. But PE and PP have one of the worst oxygen barrier properties. In this slide, we have made a comparison for common materials that have gas barrier properties. So PET is a common material that most consumers would know. And you will notice that PET has about 7 cc per meter square per day of barrier. Whereas when you compare it to a nylon-based product such as MX Nylon or even Nylon 6, the barrier property that Nylon 6 is able to provide is below 1, and MX Nylon is below 0.1. So what does all this value means? Assuming that an oxygen concentration of 10 cc in the packaging is required for the food to start to turn bad, it would only take about 2 days, mathematically speaking, for the food to start to turn bad for food packed in PET, Whereas for food packed in nylon 6, it will take about 10 days. And in MX Nylon packaging, it will take more than 3 months. All this being said, these are all estimates, and the customer will need to perform some tests on their actual product, because different fruit product is made differently in different environment and has different requirements. Next, MX Nylon, as you can see over here, has a wide processing range ranging from 240 degrees to 280 degrees, thus making it compatible with various materials such as PET, nylon 6 or 6X, and even for PE and PP. All this being said, MX Nylon sounds like a very good product, but what are the applications or the solutions for food beverage packaging? MX Nylon has been used in both rigid and flexible packaging, and in some current applications can be found in the PET bottles, for films, and even for PP thermoform trays. With the rise of retort sterilization, packaging are required to endure higher temperature during processing, and MX Nylon has been able to achieve these properties. So, in the PET bottle application, by using MX Nylon in the same preform weight as PET preforms, for example, 22 grams, we are able to achieve an improvement in barrier regardless whether the preform is made using blend technology or multi-layer technology. This will result in an extension. Oh, sorry, I repeated myself. In blend technology, MX Nylon is mixed with PET resin to achieve a blend bottle, whereas a multi-layer technology will enable a 3 distinct layers of polymers as shown in the diagram. So over here, for a blend bottle, we are able to achieve 1.8 times our shelf life, and all these small little dots you can see over here are all blended with MX Nylon. Whereas for a multi-layer, you see a solid green line. This is actually the MX Nylon layer, which cause an improvement of shelf life of 2.4 times. So most people would have traveled to Japan for their holiday and would have also bought green tea in Japan from their vending machines. I'm sure most people, when they drank the green tea in Japan, will notice that these teas are usually unsweetened. For most people, I believe, who have brewed teas before, you will notice that freshly brewed teas and teas that have been left in the open for an hour, for example, will taste very different. But in this case, how has Japan brand owners been able to pack teas into PET bottles and sell it with the same taste of freshly brewed teas? So what they have actually done is to incorporate the use of barrier technology into their PET bottles to reduce the oxidation of polyphenol counts, thus allowing them to sell their product at a more valuable and higher premium product, as you can see in this image, in this slide, where the green tea after 9 months, the color change is actually much lower as compared to a 100% PET bottle. All this being said, PET, like I mentioned just now, when we have used MX Nylon to improve the shelf life, another way to look at it is to actually use MX Nylon to retain the same shelf life by going for light weighting. So thereby achieving the same shelf life with lighter weight of the preforms. So depending on whether you're using blend bottle or multi-layer technology, you could actually reduce your shelf life from maybe 26.5 grams, for example, to 20.5 grams, and you are still able to achieve the same shelf life or even extend it further. I believe most people will also have drank some mineral waters before, and the taste can be quite different depending on the brand that is actually made, that you actually purchase from. While as much as we can brush it off as this is normal, more often than not, when we have plastics, sometimes there is some leachables that comes out from the plastics or from the water. And this is probably due to, in this case, the presence of acetaldehyde, more commonly known as AA. With the use of MX Nylon in very small dosage at about 0.5%, as compared to the previous discussions of about 5%, you will be able to get 23% reduction in the AA content. But in this case, some people will ask, so the numbers here doesn't make sense to me, micrograms per milliliter. This is actually the same as parts per million, or some people will know it as ppm. So for the rigids, we have gone through the rigids, but MX Nylon has also been used for films and sheet applications. When MX Nylon is blended into nylon films, the barrier property has also increased. For example, at 0, we are looking at maybe 50 cc per meter square per day. And with an increasing of MX Nylon in the content, the oxygen barrier increases, thereby extending the shelf life. Other properties that MX Nylon actually provides are the improvements of barrier layer, which therefore allowing increase in processability. In normal cases where we have a barrier layer in application, different materials will make the processing window tighter. However, with the use of MX Nylon, we have been able to widen the processing temperature or the processing window for thermoforming. Likewise, when MX Nylon has been used in a BOPA film, MX Nylon is also able to increase the stretchability. And as we all know, for films, once the stretch ratio increases, sometimes barrier properties and clarity of films also increases. Furthermore, MX Nylon has been able to improve the mechanical properties such as the tensile modulus and the strength of BOPA, thereby increasing the pinhole resistance. So with the increase of heat sterilization, as I mentioned at the beginning, it is now common to see food color changing as a result of oxidation. In our daily life, when we cook food and vegetables, food product will change color when exposed to high heat and oxygen. With each heat cycle, food color will change to a more duller color. For us, normally when we cook food, when the color changes, we take it that it has actually been cooked properly and suitable for eating. However, with the use of MX Nylon, we can help to reduce the oxygen ingress. When heat is applied in a low or no oxygen environment, there is minimal color change, thereby enabling the food to retain its original color. Because food that is processed usually will be cooked prior, and we do not want the color to change further. In this example, you can see that the tuna, where MX Nylon has been used, tuna has been able to retain the color of the original color, thereby enabling a higher value product. Next, in the next example, we'll take a look at mango, which is a very common fruit in Thailand or even in Southeast Asia. Given the choice, we have two mangoes, the upper and the lower, where the upper is dull and the lower is brighter. Which set of mango will you purchase? Personally, I would have chosen the bottom mango because the color of the mango is brighter. And this means it is fresher. As a consumer, our mind has been trained to identify bright colors or brightly colored mangoes as fresh. However, after putting mango through a boiling process, such as for sterilization, you'll notice that the mango would have changed color. And in this case, if you notice that without MX Nylon or without a barrier material, the mango actually becomes more dull. So therefore, by doing so, by keeping to as close to its original color as possible, brand owners are able to sell the product at a higher price, at a premium for all these products, because the consumer understands that organic or even fresh products are better for them. So I will quote a caption which I've heard during my younger days from an advertisement: any fresher and you have to peel it yourself, which I'm sure most people would have known about it. So fresh and organic is always things that we are always looking for, but it is always not so easy to achieve. So apart from food, we have other applications such as personal care or even for chemical packaging. And the products are the same. It can be used in PET bottles, polyolefin bottles, or even in films. So one of the applications that we have an example is bleach bottles. Normally, HDPE bottle is used to contain bleach. However, in one of our customers, they have moved from HDPE bottle to PET bottle. Normally, when you use a PET bottle which is exposed to bleach, after a period of 3 months, you'll notice that the PET bottle will give way due to chemical resistance issue. However, when MX Nylon is blended into PET, no cracks has been found as opposed to the 100% PET bottle, and we are able to get 12 months shelf life without any damage. Other applications such as ink and industrial pesticides has also been successfully launched with MX Nylon by increasing its barrier properties towards solvents such as toluene and xylene, which are common solvents used in this kind of applications. Other applications such as your extrusion blown polyolefin bottles, multi-layer, this MX Nylon has also been used to improve the rigidity, thereby allowing for more higher stack into their chemical application, their chemical products. So apart from the chemical industries, what about applications for personal care? So in personal care, MX Nylon has been used in barrier films to enable the use of aroma preservation and odor-proof application films, where we can see that MX Nylon is able to retain the limonene, the vanillin, and prevent all this smell from coming out from all this packaging. So with the rising of food scare, people are starting to ask, food contact approval is an important thing. And in this case, MX Nylon has been approved in various approval bodies, organizations globally, as you can see, Japan, US, Europe, and even in China. In conclusion, COVID-19 has totally changed the way consumer shops and the requirement of various packaging. Plastic should not be considered the devil of packaging, but the solution of food safety. MX Nylon has enabled the extension of shelf life and also applications that was previously thought impossible. So all these things being said, MX Nylon has also helped in making a push for environmental friendliness, making the world a better place. With this, I have come to the end of my presentation. Our contact details are as shown on the slides. We will now proceed to the Q&A. Mr. Albert, please.
Thank you for your time, Khun Thap. So also thank you for the numerous questions that we have received via Q&A and also via chat. So I will highlight some of the questions, and then I will also provide some answers, and let's also get some feedback from Japan as well as our partners. So number one question that we got was cost compared to conventional resins, as well as compared to recycled resins. So let me start, and maybe after that, Ryan and Miyabe-san can also add in. So cost of nylon, MX Nylon itself is generally a little bit higher compared to the other commoditized packaging resins. But if you do a proper cost benefit analysis, you will actually be able to achieve a much higher, a longer shelf life when you actually adopt certain levels of MX Nylon. And the benefits outweigh the cost in almost all circumstances, especially for CSDs, and also especially for some special formulations that require also oxygen absorption plus barrier. And we work with various partners to also provide the solution. And especially in Thailand, I think a lot of people are looking at these solutions like coconut water, etc., a booming market, as well as soya bean drinks and also teas. So there are solutions available, and if you contact us, we will actually provide further information on this. Total cost benefit analysis, the benefits outweigh the cost substantially. And there was this question about recycling. And actually, one of the slides that Ryan mentioned, whereby MX Nylon is able to provide this function of absorber of AA, etc., the leachables. Actually, when there's adoption of recycled content into virgin when we blend it, MX Nylon, when added into all these resins for the injection molding, you are able to actually absorb the AA and ensure that there's no change and impact to the taste as well as the quality of the beverages or non-food products as well. Yeah. Maybe Ryan and Miyabe-san, you want to add to the first question about cost as well as maybe when used in recycle?
I will address the recyclability stuff first, because I think cost has already been mentioned by Mr. Albert. So with regards to recyclability, I think most of the people for MX Nylon, the recycling has been approved by Europe market for non-food application, because even like in Thailand, recycling for food application is still under review because of the worry of contamination from post-consumer. So therefore, recycled products are still not allowed in Thailand. At least that is what I know as of now. And most of the time, globally for recycling, people are still looking at PET as the biggest recycling, and solutions are being considered for polyolefins and other materials. So as of now, MX Nylon has been approved for recycling in Europe, but for other places such as Japan, where we have been using the materials, has also been approved. But for outside of these two locations, I think work is still ongoing, and even for the recycling of this kind of materials, it's still ongoing, and solutions are still being found.
Okay, so let us go on. Second question is actually similar to what Ryan has mentioned. It's about sustainability. And I just want to add that actually, yeah, so we are in the process of enabling the adoption of recycled nylons in actually global locations where legislation is already in place. So we are actually in the process, and we should be able to qualify for most locations in a very short time. Third question is actually about existing equipment. Well, the question actually stated about blowers and extruders. So I think at this point in time, I also want to talk about injection machines. And because our industry partners, Mover Color, is also here. So I want to actually raise this point about the adoption of barrier technologies in both the rigids as well as the flexibles. The cost of adoption, if the solution is required immediately, the cost of adopting MX Nylon into, for example, PET preforms, is actually going to be very fast, and the cost is actually quite minimal. And the reason why I say this is I think when Ryan mentioned about adoption of MX Nylon into blend technologies, be it even in rigids or in flexibles, we have partners like Mover Color, who are using gravimetric dosing. I will actually pass this over to Mover Color, maybe Mr. Larson or maybe Mr. Anders, for a short sharing of your technologies that can enable accurate dosing. If you don't mind, Mr. Larson or Mr. Anders. Maybe you have to unmute.
Yeah. Okay. Yes, that will be fine. Thank you very much. Am I visible?
So, Informer, maybe you can put Mr. Anders' video.
Okay. Thank you very much. A big thank you, first of all, to MGC for the opportunity we have to discuss various solutions in the industry of packaging. Mover Color, we are a Dutch company, and we focus only on gravimetric feeding, so feeding by weight. And where we come into the picture here is when we have functional additives as MX Nylon, that it's critical to put the correct amount of material into the blend, both because the end user will need to guarantee the longevity of the end product, and also these additives are of course a cost which needs to be fully controlled. So another aspect of using gravimetric feeders rather than blenders, feeder basically we only feed the additive into the injection molding machine or to the extrusion system. It's not possible basically to blend large amounts of preheated polyester. We need to feed it just before the entrance of the injection molding screw or the extruder screw. So another aspect of feeding by weight, which is gravimetric feeding, is that we have then the ability of having online quality control. We measure the flow of each material, the percentage of each material, so that you will have a full record of data of each ingredient that is included in the recipe. And that comes back to cost. Cost again, we need to control the cost, and by controlling the additives, we can control the cost. And most of the cases, we have a way of finding very attractive return of investments when it comes to colorants, another way of blending and introducing colorants into plastics. But by feeding them with a good software and a good engineered machineries, we can also find actually a way of saving costs in a competitive packaging market.
Thank you, Mr. Anders, for your explanation. Maybe we can go on to other questions. Informer, if you don't mind, can you put me back into the video? Yes, thank you. So I think we are getting more and more questions. So the next, before even we go on to the next question, and actually we have various success stories with Movacolor and their partners in Asia. With the adoption of precise dosing using Movacolor gravimetrics, we are able to actually further reduce the costs that is borne when you adopt simple solutions like blending of MX Nylon into the resins, be it for injection molding or be it for extrusion. And at the same time, of course, if you are able to do that, you are able to also achieve, of course, maybe possibilities in lightweighting, which eventually results in, of course, producing less greenhouse gases. Next question we have is actually about the comparison with EVOH. So I will leave this question to Ryan and also Miyabe-san if there's any thing that Miyabe-san would add. So Ryan, would you mind actually maybe giving a simple comparison verbally for EVOH in terms of performance, heat cycles, humidity, etc.?
Yeah, sure. So for MX Nylon and EVOH, I mean, yes, EVOH is also a barrier material like MX Nylon. However, the requirements or the applications for EVOH is very much different from MX Nylon, in the sense that MX Nylon is usually catered for high moisture, high water activity products. And also when products go through retort sterilization, for example, and goes through heat cycle, EVOH tends to undergo this phenomenon known as thermal shock. So barrier properties actually dropped after retorting, and therefore increasing the total packaging oxygen concentration. Whereas for MX Nylon, after going through retort application, the barrier properties does not change much, and therefore we are able to have a lower barrier properties as compared to EVOH. Okay.
Yeah, so thank you, Ryan. Yeah, so actually, I just want to, so Ryan mentioned we have higher barrier properties compared to EVOH, especially for high water activity or wet products. So long ago, when we started marketing of barrier materials, there was a lot of guesswork into what is used, what should be used, EVOH or MX Nylon. And I think after a long time, we've finally been able to separate the two. So I shan't comment too much on EVOH, but we have found out that MX Nylon is the suitable material for wet products and of course liquid products, and especially in high humidity environments like near to the equator or tropical locations. And lastly, also for products that require heat process. So for heat processes, be it not just even for retort, even for pressurizing temperatures, if the pressurizing duration is high, and other applications, not just retort, and maybe even other forms of sterilization in pharma, etc. So when you're able to use nylons, especially MX nylon, the heat shock and the loss of the barrier post-shock, the reversion is quite immediate as compared to the alternative EVOH. And the other thing I would like to add, being a nylon tube means that there is this added benefit of pinhole resistance. So when you're using OH groups, right, your alcohols, etc., there are a few challenges like actually if the film is it's not flexible, it's actually quite rigid. When you crush it, of course, the chances are for non-nylons, there's a high chance that delamination will occur. When you're using nylons, especially MX nylon, this occurrence will be minimized. I would also just like to add that MX nylon for flexibles, and this is where also maybe mover color can also be adopted, is actually we can actually dose MX nylon into BOPA. And you're able to actually increase the barrier properties of the nylon, BOPA, and also achieve something that is quite interesting. You can actually increase or achieve something called easy tear nylon properties. However, of course, based on different geographies, there are different legislations that are in place. So I will also urge interested parties to look carefully at how you can or cannot adopt these technologies for blending MX nylon into nylons for flexibles to achieve thinner gauge nylons, higher barrier nylon flexibles, as well as the easy tear properties. Next question is an interesting question. We had a question asking about the comparison of MX nylon versus amorphous nylon, or maybe amorphous nylon blends like PA6I and 6T. Maybe I will leave this to Ryan to respond first.
Okay. For MX nylon, okay, for MX nylon and amorphous nylon such as PA6I, 6T, they are of different categories. MX nylon can be blended with nylon 6IT to actually achieve better barrier properties in the processing of BOPA. So I think you can use it together to further increase. So amorphous nylon, it's higher transparency if I'm not wrong. Whereas the processing conditions I think are quite similar. So I would believe the only considerations would be the processing, the gelation of the two different materials.
I would like to add to Ryan's statements, so I will come from a commercial viewpoint. So amorphous nylons currently available in markets are really high priced. So compared to the MX nylon that we supply, the cost can be easily doubled. So of course, from a cost factor, I think well, it would be good if you are trying to achieve some transparency, etc., to consider a combination of the nylons. But cost-wise, if you're only looking at the amorphous compared to MX nylon or simple nylons, you can't compare. The amorphous nylons are expensive. At the same time, please also understand, if I'm not wrong, also amorphous nylons at the present moment you are unable to reheat. So once you do molding, you can't actually do blowing anymore. So it is a one-shot single-stage process, whereas of course the typical rigid systems using ISBM, using injection molding machines, you are able to do a preform, keep the preforms, and after that blow at a later stage. So the practicality of amorphous nylon receptacles compared to MX Nylon with PET receptacles, etc., is a little bit different. So the value proposition would be different. So probably amorphous nylons would be more suitable to certain other products instead of food and maybe industrial products. Yeah. So, and we have more questions coming in. So the other question that we have, which is also quite interesting, is about tomatoes. So you have products that are tomatoes, and you want to find out if MX Nylon can actually help to resolve extend the shelf life of any products using tomatoes. And the simple answer is yes, because one of the key issues with tomatoes is browning, or the oxidation of the colors in natural tomato. So you are able to reduce the amount of oxygen incursion into the packaging. You are able to slow down the aging of the color, the darkening of the colors of tomato, as well as certain interesting antioxidants. And in the case of tomatoes, I think one of the key elements is also vitamin C count. So if you are able to reduce oxygen ingress, you are able to reduce the oxidization of the vitamin C's, which will impact also the value or the health values of the tomato. But there are better solutions in combination with MX Nylon. So normally for highly oxidizable foods, as I mentioned earlier, there are also solutions where we work with partners to enable the adoption of active barrier solutions. So MX Nylon itself is a passive barrier, but we have various partners from Japan, from US, who are able to provide an active solution whereby not just taking care of the incurring, the oxygen coming in, but at the same time, they are able to absorb the oxygen that's already inside the packaging. And this enables something called TPO, total packaging oxygen, to be at a 0 level over an extended period of time. This is a pretty new technology, but it is now very widely adopted now in Asia. It is an emerging choice for a lot of beverage companies, dairy companies, even juice companies. Please do not hesitate to contact us, and we will tie you up with different partners to enable the sharing of these technologies in this region. We have another question, and this pertains to also, give me 1 second, the difference between the comparison of MX Nylon versus aluminum. So this is an interesting question. I will keep my comments, and maybe Mr. Ryan and Mr. Miyabe can come in later. So of course, when you use vacuum metallization, metallized films, or when you're using pure aluminum films with a distinct aluminum layer, there are a few things that you encounter. So number one, of course, the equipment is more expensive. Second issue is actually you will not be able to achieve high barrier with transparency. And moving forward, I think due to the requirements of food safety or even product accuracy, where the barcoding, etc., let's say even not food, right? For industrial products, they want the actual barcoding or the QR codes to be on the product itself. Then they require transparent windows for the scanning to be able to scan the actual product to reduce the chances of wrongful packaging or failures. At the same time, also enable the customers to be able to see the products inside in terms of food to feel safe. So the adoption of MX Nylon enables the transparency for both food and non-food packaging. Of course, aluminum itself, you can achieve almost zero OTR and WTTR, but the key issue is cost and the loss of transparency, right? Yeah, and let us go on to certain other questions. So we have gentleman Kun Chadapong also mentioning about this retop pouches using aluminum nylon for tuna, and there's a shelf life of 2 years. if we use MX Nylon, shelf life of report back 2 years or more. So Mr. Chatterpon, we actually already have certain advanced technical solutions that we can propose to you. This is from another division within MGC. We will contact you after this webinar. We have actually what we call active barrier. That means we are able to provide barrier and we are also able to absorb oxygen, be it in the lid or now we are trying also in the tray. So we will be able to provide some solutions to you, and we are confident that those solutions are able to provide shelf life of maybe 3 years and more. It is a proven solution. It's FDA approved and it is also US DOD approved. That means for non-civilian applications. So we will be more than willing to share with you post-webinar. And I think there was a simple question. A few other questions that came in. How do you use PET resin for bottle application? So for the bottle applications, I think Ryan shared with you earlier in the presentation. Yeah, for ISBM, there are 2 ways to use MX Nylon. Very simple way, and it's been tested, and actually we succeeded in some trials in Thailand in some of the major preform manufacturers. We actually just simply adopted a dosing machine from a partner like Mova Color, all their partners, and we did the test in Thailand. It was just using a dosing machine, a gravimetric dosing machine, using existing injection machines in the preform manufacturers in Thailand, and the whole process actually took very short time. When the resin came, when the machines were set up, we were able to actually completely do the trials within 1 day, and it was running. So if there's any opportunities for you to look at the low-cost adoption like blends, please let us know. We will respond to you very quickly. Of course, if you have further capex that you are having, then the other alternative is, of course, you can consider multi-layer machines with a distinct MX Nylon layer. However, the cost is a little bit high compared to a simple blend solution. But that being said, of course, multi-layer machines now also come in from various suppliers, and the cost of the multi-layer systems have also come down dramatically, and equipment, in fact, is now available already for from some preform manufacturers in Southeast Asia. You can also consider, even now, not the big machines, you can also do smaller machines. Instead of 72 cavities, there's an option for 36 cavity adoption of multi-layer machines. So there are various options now available for multi-layers that you can consider, but the key difference will be the speed of adoption. Blends will be a lot faster. Multi-layers, of course, you have the commissioning and the commissioning periods. It will take quite a lot of time, a few months minimum. And of course, the cost can be a little bit higher. Yeah. We have a question about the comparison of MX Nylon, EVOH, and PP. So so we have data, but it is not in the pre-prepared presentation today. So I will just give you a rough idea of the difference in the barrier properties. And I think in this case, your interest will be on oxygen barrier properties. So if I say that PP is for typical PP, in the flexibles today, maybe 20 to 30 micron thickness. Actually, the OTR of PP can go to maybe 1 to 2 liters a day, 1000 cc to 2000 cc per meter square per day at 1 atmosphere. So 1 liter of oxygen goes into a 1 square meter area, right? If you're talking about EVOH and MX Nylon, we are talking of things that are like 10 cc to 20 cc to 30 cc base. So you are talking about a totally different universe, whereby you have 20 to 30 cc per square meter going into the packaging per day, whereas compared to the others, like the olefins, the PEs and the PPs, you actually have a few liters of oxygen going in. So this is the key difference. You're able to actually slow down oxidation and extend shelf life of the products when you use active barrier packaging. And I think we mentioned there's a difference. The difference is actually on the types of products. So if the product is high moisture, high liquid, and CSD, for example, or typically wet and moist products, then the difference is, of course, MX Nylon is the preferred solution. At the same time, when the products need to go for some heat process, then MX Nylon products do not suffer from any report shock, so that the post-heat treatment, even though the PP or the PE can hold the seal in place, actually the barrier properties have been greatly damaged in terms of EDOH, whereas MX Nylon, the reversion of the barrier properties will come in a very short time. We will give you further information if you provide us your contact details, and I believe yes, you will given the details. Yeah, and please also note that we work in collaboration with other nylon manufacturers to enable blend nylon solutions in blend solutions flexibles as well. Last question that we have, and we are running a little bit early. So how do you recycle nylon? So actually, when we mentioned, I will give this question to Ryan, so that Ryan can maybe give some feedback for the recycling of nylon.
Okay. For nylons, the recycling of nylons for blend technology there is no separation for PET and MX Nylon when it is blended, because the two resins have already been blended together. But when we noticed, like in the previous presentation where I have mentioned that the reduction in acid aldehyde for all these bottles, we noticed that when the MX Nylon is blended in PET, the properties of the PET recyclates, the rPET, can still be processed, and the IV drop is actually lower. So in terms of recycling, most of the time, MX Nylon is used for textile application, not in direct contact for food applications. So I hope this answers your questions.
I would also like to add to Ryan's statement. So actually, the recycling of nylons into food beverages and containers, the approvals are actually ongoing. We've gotten approvals in Europe, in Japan, and also we're in the process of getting the final approvals from US. So as Ryan mentioned, MX Nylon to a certain dosage is allowed in the recycle stream, and all will be allowed in the recycle stream. And in fact, MX Nylon actually increases the practicalness, the usability of rPET, because it's able to absorb AAs and FA. And with that, it reduces the possibility of leaching. And when I mention rPET, I mean mechanical recycled PET, right? Not other forms of PET recycling. So we are talking about the lower cost of mechanical recycling. So we believe MX Nylon is contributing to the usability of rPET, or the increase in the dosage of rPET into virgin PET during the manufacturing of bottles as well as flexibles. We have additional questions coming in. So does MGC have production plant in Thailand, and which product do they produce? So MGC has many production plants in Thailand. However, we do not have the nylon plants in Thailand. Our MX Nylon specialty nylon plant is sited in Japan and in US. So the cargo comes from US or comes from Japan. Yeah, I hope that answers your question. However, the application of these nylons into preform manufacturing is very easy. If you're using dosing systems or even multi-layers, if you have the multi-layer equipment. And another question that we have is, I think we have a beverage manufacturer in Thailand. So we will contact you shortly we will be able to provide, and if you're doing beverages like fruit juices or even beverages, I believe MX Nylon with certain other partners will provide a very good solution to your requirements. And I want to add one last statement. So actually in the world, there is something called ultra high barrier flexibles. And that technology is already available in Europe, and those technologies have also been successfully shown to be adopted in Southeast Asia. So we hope that if you have some interest on these ultra high barrier films, and these are metallized films compared to the standard olefin metallized films, they do not suffer from this problem of easy delamination. And the reason for this is because MX Nylon together with amorphous nylon enables very strong adhesion of the vacuum metallized layers onto the nylon, onto the olefins. And this is some technology that you can look at, and if you contact us, we will redirect and also provide information to you. Ultra high barrier films using existing multi-layer olefin extrusion equipment in collaboration of MX Nylon, and you're able to achieve OTRs of 0.13 or 0.17 cc per meter square per day, almost close to aluminum. So I hope that information is interesting to you. You can contact us and we will provide information to you and redirect you to partners that enable that solution to be adopted. Finally, we have 2 or 3 minutes left. I would again like to encourage you to contact us in Singapore as well as in Thailand if you believe that you are able to communicate better in Thai language. So the contact details are on this page that you are seeing. And also don't hesitate to let us know if you have interest in both rigids and flexibles. We have been in the industry for a long time. We are able to provide systems in conjunction with our partners like Movacolor to provide quick solutions like blend solutions, and also more cosmetically appealing but slightly costly solutions like the multi-layer machines. And of course, recently much reduced prices to any customers in Thailand and around the region. So feel free to contact us. We will also contact all those who have posted questions that we are unable to answer properly today. Once again, I would like to thank Informal Markets. I would also like to thank Ryan for his effort. I would like to thank support to MGC Japan as well as our industry partners, Movacolors, for today's support. And lastly, Kopun Cup. Thanks to our Thai attendees as well as the global attendees. Thank you for your time, and we hope to hear from you. Thank you so much. Thank you.
ค่ะ และในนามของ Informa Market และบริษัท Mitsubishi Gas Chemical Singapore นะคะ ขอบคุณวิทยากรและผู้เข้าร่วมฟังสัมมนาทุกท่านนะคะทางเราก็หวังเป็นอย่างยิ่งว่าท่านจะได้รับข้อมูลที่เป็นประโยชน์ต่อการพัฒนาบรรจุภัณฑ์ของท่านในอนาคตนะคะแล้วพบกันใหม่ในงานสัมมนาออนไลน์ครั้งหน้าสำหรับวันนี้สวัสดีค่ะ